Okay, back folks. So what we've got over here are two different graphs. We use a lot of graphs in economics. I'm sorry about that. I've actually had students that were not pleased by the fact that we use graphs, but that's kind of what we do in economics. So if you're going to major in economics, become comfortable with graphs. If you're not, just look at it this way. 101 and 102, those are probably the only two econ classes you have to take, and after that you're done with graphs. All right, so the first graph we have on the top over here is a simple demand curve. You can't really get much simpler in terms of demand curves because, as you'll notice over here, all the prices are laid out in 1 unit increments. So we've got a price of 8, 7, 6, 5, 4, 3, 2, 1. And then we've got units over here that are also laid out in 1 unit increments as well. So we've got a quantity of 1, 2, 3, 4, 5, 6, 7, 8, etc. Down here we have what's called a total revenue curve. Now let me stop over here and mention that this is the first time we're really going to be talking about money or anything that kind of approaches the idea of profit. Okay, in order to get to profit, which we're actually not going to be talking about, we have to first start out with total revenue, and then we would subtract out total costs. Some of you may have taken accounting, and you may be familiar with a thing called an income statement. And on an income statement, your top line is called your sales, and then you subtract out cost of goods sold, and you get to gross profit, and then you subtract out all your other expenses, and you get to a thing called net profit. We are not going to be talking about profit, but what we are going to be doing is we're going to be talking about total revenue. So what is total revenue? Total revenue is price times quantity. So if you price something at 5 and you sell 10 of those, all you do is multiply 5 times 10 and your total revenue is 50. All right, why is that important? Because a lot of times what happens is firms will try to, or firms may have a cost structure that allows them to maximize their profits by maximizing total revenue. Or maybe firms aren't exactly in the goal of maximizing profit on a quarterly basis. Maybe they feel that if they maximize their total revenue, that might over a longer period of time, that might help them maximize profit. So we're going to start out with total revenue, and we're going to calculate the total revenue, which is this curve down here, by looking at prices and quantities from our demand curve over here. So imagine that you have a product, you're throwing it out on the market, it's a new product. Maybe there isn't really anything like this, and you have no idea what you should price this product at. So let's just say that you throw the product out on the market price of 8, and lo and behold, because maybe the price is high, you only sell 1 unit. What would your total revenue be at a price of 8? Your total revenue would be 1 times 8. So we come down here to the total revenue graph, and you'll see that we've got a point over there at 8. With so our total revenue is 8 and our quantity is 1. All right, let's say you can take that back somehow and maybe not sell it at 8. Maybe you can throw it out on the market at 7 somehow. So you lower the price from 8 to 7. First law of demand says that as price goes down, quantity demanded goes up. And lo and behold, when you charge a price of 7, right here, you sell 2 units. What's your total revenue? 2 times 7. 2 times 7 is equal to 14. That's interesting. We lowered the price from 8 to 7. Our total revenue went up from 8 to 14. That's a pretty good indication maybe we were charging too much. So again, imagine you could take that back. You could take back that price of 7 and this time throw it on the market at a price of 6. Okay, first law of demand says that as price goes down, quantity demanded goes up. You find out that when you put this product on the market at a price of 6, you sell 3 units. What's your total revenue? 3 times 6 is equal to 18. We come down here and we can plot a point for 3 and 18 on our total revenue line. That's interesting. Total revenue went up. We drop the price, we keep dropping the price, and total revenue goes up. Let's try this one more time. Maybe what we really need to do is drop the price down to 5. Maybe 6 is too high a price. Okay, so we drop the price to 5. Let's say at a price of 5, we sell 4 units. What's our total revenue going to be? Our total revenue is 4 times 5. That's equal to 20. Wow. Every time we drop the price, our total revenue goes up. Maybe what we need to do is drop the price one more time. So now what we're going to do is we're going to drop the price from 5 to 4. First law of demand says that as price goes down, quantity demanded goes up. And so sure enough, this time we sell 5 units instead of 4 units. But what's happened to our total revenue? Our total revenue has not changed. So why did our total revenue change initially? Our total revenue changed initially because we were on the elastic portion of the demand curve. Anytime you're on the elastic portion of the demand curve, if your goal is to maximize revenue, I'm not talking about maximizing profit. It might help you maximize profit, but if your goal is to maximize total revenue, then you should lower your price. However, that only works for some period of time. After that, what's going to happen is you're going to transition into what we call the unit elastic range. In the unit elastic range, it doesn't matter if you charge a higher price and sell less units or a slightly lower price and sell more units, your total revenue is going to be the same. In other words, 4 times 5 is equal to 20 and 5 times 4 is equal to 20. There's no difference. All right, let's approach this from the other side. Let's imagine that instead of throwing our product out there at a price of 8, this high price way up here. We had no idea what a good price would be for our product, so we just throw it out on the market at 1. Okay, so at a price of 1, that's this over here. I hope you can see the cursor, by the way. And a quantity of 8. What's our total revenue going to be? 1 times 8 is going to be 8. What are we going to do with that information? We're going to come down here to our total revenue graph. We're going to locate a quantity of 8 and we're going to go ahead and locate a total revenue over here of 8 as well, and we can put 1 point up there. So 8 doesn't seem like a lot of total revenue. Maybe now instead of pricing it too high, we're really giving it away because we're pricing it at $1. So let's say we could take that back. Just imagine they're do-overs. There really aren't, but imagine we could do this over somehow. And this time, maybe what we're going to do is we're going to throw it out on the market at a higher price, a price of 2. Well, first law of demand again says if price goes up, quantity demanded goes down, right? So this time we're not going to sell 8 units, we're only going to sell 7. But 2 times 7 is equal to 14. So when we come down here to the total revenue graph, what do we have? We've got 7 units and a total revenue of 14. Wow, that's interesting, huh? We raised the price and our total revenue went up. So that's pretty good indication that maybe we were giving this product away. We shouldn't have been selling it so cheap in the first place. So maybe what we do this time, again, imagine there's do-overs. There really aren't, but just imagine there are. We take this back and we decide we're going to sell this product for a price of 3. First law of demand says that as price goes up, quantity demanded goes down. But our new quantity demanded is 6, so 3 times 6 is equal to 18. 18 is more than 14. Where are we at on our total revenue line over here? We're at this point. So, gee, that's interesting. Every time we raise the price, our total revenue goes up. Wonder if that'll happen one more time. So we do. We're gonna do that. We're gonna raise the price from 3 to 4. We're going to see the quantity go down from 6 to 5, but we're going to see our total revenue rise from 18 to 20. That's good. Our total revenue keeps on rising. Maybe we should try this one more time. Well, if we do, we're going to encounter the same thing that we did when we were dropping our price from a high price. Why is that? Because we're transitioning out of what we call the inelastic range into the unit elastic range. Whenever we have a product whose price elasticity of demand is inelastic, we owe it to ourselves, and I would say, by the way, you owe it to your best customers to raise the price. Now, why do I say this? If your product is priced too low, you're not making money, but more importantly, there are people who may be buying your product that don't value that product at a higher price. Therefore, the people who actually do value the product at a higher price may not be able to get the product if, let's say, you just can't make it fast enough. So the people who don't value it as much are getting the product, and the people who do value it as much may not be able to get it right away. So if you charge a higher price for your product, you'll guarantee that there'll be enough supply on the market for those people who value that product. Now, I should also point out something about unit elasticity. Some firms look for a price point that is unit elastic. I'm not going to say that I've ever worked at Apple, but one of the things that you might notice about how Apple prices its products is that it prices products in the $400 to $500 range. Why is that? These are new products that oftentimes have never been sold before. Like think of the iPhone before it came out. They landed on a price of 500, or the iPod or the iPad. They have certain price points, and those price points are likely to be fairly close to unit elasticity. Why is that? Because that might be maximizing their total revenues. And if their costs behave in a certain way, that might also, by extension, maximize total profit. I'm not saying it is. I've never worked for Apple. I don't know what their cost accounting looks like. But the point I'm trying to make is it's not unusual, oftentimes, for you to see companies searching for this unit elastic price. Why is that? Because once you're in the unit elastic range, if you go out of the unit elastic range, you're no matter what you do, you're going to be shooting yourself in the foot. In other words, like if you were charging a price of 5 and selling 4, and you decided to raise the price to 6 and you only sold 18, your total revenue would go down. If you're in the unit elastic range and you're charging a price of 4 and selling 5, and you decided to lower your price, your total revenue would also go down. So sometimes maximizing total revenue might be the sweet spot, or the price range that people are looking for, this unit elastic range here. All right, so here are some price elasticities of demands that have been calculated for various products. This one's interesting. Newspapers 0.10. By the way, this is an old calculation. But I think the newspapers have kind of caught on to it. They're raising their prices even as their circulation is going down, because I guess the people who buy or get their news from newspapers are willing to pay more. In the old days, I think the revenue model for the newspapers was get it in as the hands of as many people as you possibly can, and then tell your advertisers that it has this huge circulation and they should pay you more for ads. Here's one that's pretty interesting. Bread, 0.15. If you're Vons or Ralph's or Sprouts or Whole Foods, you probably know that the price elasticity of demand for bread is 0.15. Why do I say that? Because they have all that scanner data, checkout data. They know what happens when they tweak the price of bread here and there. So there's probably a reason why they keep that price low. There's a lot of different theories on this. Some people say that it brings people in. If you charge people a low price for bread, that's something people buy regularly, so they'll come in for bread and then fill up their shopping cart with other things. Let's see, another one that I think is pretty interesting. Where is it? Motor vehicles, 1.14, pretty close to unit elastic. And by the way, I don't know if this is the sticker price or if it's the price that the car finally sells for. Why might that make a difference? Because if you think about how cars are sold, there's always a little bit of bargaining that could be going on in the process, right? So maybe it pays to set people's price expectation a little bit higher than what they're willing to pay, so that if they get the price down at the dealership, they feel like they've gotten a good deal, right? So that's pretty close to being revenue maximizing unit elastic. Here's one: restaurant meals, 2.25. So what that means is a 1% increase in the price will lead to a 2.27 percent decrease in revenue. So this is probably too averaged for different types of restaurants. If you were talking about people who let's say eat at Ruth Chris Steakhouse, they might not be as price sensitive. Whereas if you're talking about people who maybe eat at McDonald's, they'd probably be more price sensitive. But the takeaway here, the thing that I want you guys to think about is, if you're in an industry that where your customers are price sensitive, and let's say your costs go up, let's say the minimum wage goes up as an example. You have a lot of minimum wage workers, and now your labor costs have gone up. One of the things a lot of people say is, well, they'll just raise their prices. And the answer is not always. And the reason they won't do that is because if they know that their customers are price sensitive, then they're shooting themselves in the other foot. They're going to wind up raising their price, and their sales are going to go down at the same time that they've been forced to pay higher labor costs. So that doesn't always follow. Just keep that in mind. Bear that in mind as you go through life. If it was easy as raising your prices, then everybody would do it all the time, right? All right, so I want to talk a little bit about looking at elasticities kind of graphically so you get an idea of what's going on. If we have a demand curve that is for a product that's relatively elastic between 2 points, think of it as being like kind of the bunny slope on at a ski resort, right? It's very gradually sloped. It's not that steep. And what these boxes are telling us is these represent total revenues. So we can charge a price of P2 and sell Q2, and then this would be our total revenue. Or we could charge a slightly lower price of P1 and sell Q1, and this would be our total revenue. And I think if you look at this graphically, it becomes obvious that charging a lower price will get you a higher total revenue in a case like this than charging a higher price. Okay, let's say we have a demand for a product between two points that is very inelastic. That's like saying the slope of this hill is very steep. So it would be like a double diamond run on a ski resort, right? So P2 is a higher price than P1. It's actually significantly higher. Q2 is less than Q1, but not by that much. So by looking at these two rectangles that represent total revenue, it looks like charging a price of P2 and selling Q2 will earn more total revenue for the company than charging a price of P1 and selling Q1. In a case like this, it makes sense to charge the higher price. When we talk about unit elastic, we could be talking about unit elasticity between 2 points, either for a demand curve that is straight lined or one that is curved concave. So the only thing that we're saying is between P2 and P1, we're going to wind up earning the same total revenue. Why is that? Because if we charge a price of P2, we sell Q2. This box over here represents the total revenue if we charge P2. If we lower the price to P1, we sell more Q1. This box over here represents total revenue. And what you have to imagine is that both these boxes are equal to each other. So it doesn't matter if we charge P2, sell Q2, we're going to make the same total revenue if we charge that price compared to charging P1 and selling Q1. Okay, and there's two types of curves that can connect these points. One is a straight line curve, and the other is a concave curve. All right, perfectly elastic demand. If your demand is perfectly elastic, that means that you don't have any ability to raise your price. So the only way that you could really make more money would be to supply, or make more revenue, I should say, would be to supply more, to work harder. See, what you have to imagine is that there are these supply curves that intersect the demand curve over here. If you supply this much, Q1, then this is your total revenue. If you supply more, then this is your total revenue. So you have to work harder. Nobody ever wants to do that. Try to avoid being in this type of industry because you don't want to work harder for your money. You want to work smarter for your money. All right, what would happen if we had a demand for a product that was perfectly inelastic? What this means is that buyers of this product are completely price insensitive. They don't care what you charge them. You can charge them P1, you can charge them P2. They're not going to reduce the amount that or increase if it was a lower price, the amount that they're going to buy. This is a type you want to find a product that's got a demand like this, because if you do, that means that the way to make more money is just raise the price. It's something that for whatever reason people can't live without. All right, price elasticities of supply, same thing. If we have a supply curve that's very elastic, not perfectly elastic like down here, but very elastic, it means that producers are price sensitive. A small change in the price will get them to supply a lot more onto the market. So there's not much difference between P1 and P2 over here, but there's a huge difference between Q1 and Q2 over here. If we have a price elasticity of supply that's relatively inelastic, what that means is producers are not price sensitive. In other words, P2 is a much higher price than P1. When the price goes from P1 to P2, how much additional supply do producers supply to the market? Not that much. Q1, Q2. They kind of shrug their shoulders. They say, okay, I guess I can supply a little bit more. And then if we talk about unit elasticity with respect to the supply curve, what we're saying is a 1% increase in price will lead to a 1% increase in quantity supplied. Or imagine that there's a 2% difference between P1 and P2. In price, there'd be a 2% difference in quantity supplied between Q1 and Q2. And then I mentioned you never want to have a product whose demand is perfectly elastic. The only thing that's worse than having a product whose demand is perfectly elastic is to have a product whose supply is perfectly elastic. Why do I say that? Because you're at the mercy of the market. In other words, you're willing to supply as much of this product as anybody's willing to buy at a price of this, whatever that happens to be. You're essentially taking the price, but you're also at the mercy of the market. How much you actually sell depends on demand for your product. You're willing to supply as much as anybody wants to buy, but if people don't want to buy the product, then you're sort of you've got some problems. Let's put it that way. If we had a supply curve that was perfectly inelastic, what we'd be saying is that producers of this product are completely price insensitive. It doesn't matter how much how much money you throw at them, they're not going to supply more. In other words, P2 is higher than P1. Did that induce producers to supply more? And the answer is no. And maybe something like this would happen because of some kind of a supply constraint. Maybe it's just physically impossible for producers to produce more, and so throwing more money at these producers isn't necessarily going to get them to produce more. It might get you the product, but it's not going to increase supply, at least in the short run anyway. All right, so what is the formula for the price elasticity of supply? It's basically the same formula, only in the numerator, we're looking at the percentage change in quantity supplied. Remember when we were looking at E sub D, the price elasticity of demand, we had the percentage quantity demanded divided by the percentage change in the price. Well, this is the price elasticity of supply, E sub S, which is the percentage change in the quantity supplied divided by the percentage change in the price. Now, do you need the absolute value sign here? And the answer is probably not. I mean, in this class, we're going to assume that the supply curve is upward sloping. Therefore, if you take the absolute value of a positive number, it's still going to yield a positive number. If you want to do that, you certainly can. But remember, our assumption is that supply curves in this class are upward sloping. Does that make sense? All right, I'm going to end it here because I don't want this video to be too long, and then we'll pick it up over here in looking at how the price elasticity of demand can change depending on points we select. Thank you very much.